Hello and welcome back to the Jungle Histology online training series. My name is Ken Longenecker and this is the 7th of 9 modules designed to teach anybody who's interested how to perform the methods my colleagues and I use to do rapid reproductive analysis on coral reef fishes. The topic of this module is size-specific sex ratios. Now this is a concept that many people aren't familiar with, so I want to define it briefly right now. This is the phenomenon of sex ratios varying predictably with size amongst mature individuals. Well, why am I dedicating a whole module to this phenomenon that many people might not have heard of? It's because it challenges one of the current paradigms in coral reef fisheries. Many people are familiar with this concept that larger fish produce more eggs. I'm going to tell you right now that because of a technicality, this statement may not be true. What is true is that in general, larger females produce more eggs. And this is where the size-specific sex ratios come in. It turns out that for many coral reef fish species, females just don't get that large. So if your largest fish aren't females, those largest fish can't be producing more eggs. I'm going to show you an example of that with real data next. Here's that relationship that most people are familiar with. We have female length on the x-axis and egg production on the y-axis. And it turns out that as females get larger, they do produce more and more and more eggs. Now let's take a look at size-specific sex ratios. On the bottom graph, I've put fish length on the same scale as the top graph, but on the y-axis we have percent females. What you can see is that the species is made up of 100% females up until about 70 millimeters. Then the percentage of females drops precipitously until about 90 to 92 millimeters, and you have 0% females at larger lengths. Now I've combined the information in those two graphs. Look what happens to estimates of egg production per individual when we take into consideration the likelihood that that individual is a female. It turns out that in this species, smaller sizes are actually responsible for more per individual egg production. And I want to give you a statistic now, just so you don't think I'm making a mountain out of a molehill. Now we don't know size-specific sex ratios for a lot of coral reef fishes, again because this concept just hasn't hit most people's radar. But for the species that have been studied, it turns out that in 71% there's a decrease in the percentage of females as length increases. We've seen a few patterns so far. The first and simplest one is that the percentage of females remains relatively constant, then drops in almost a straight line fashion, and then becomes relatively constant again. A second and more complicated pattern is a peak in the percentage of females, which then tapers off. And just to be clear, sex ratios won't always vary with length. Here's an example where sex ratio seems to be relatively constant throughout the size range of the species. Another bit of information that I should share with you is that you may see that the percentage of females actually increases with length as well. So let's go to our electronic data for an example of how we would examine size-specific sex ratios. This concludes Module 7. I'd like to take this opportunity to thank our funders